So a soldier lowers the American flag from the top of the pole at 0.75 meters per second, meaning what? Tell the person next to you. Meaning what? Can you say it? Okay, you should have said something like this. That for any change in seconds, the change of the flag's height is some number times that change in seconds. And what number is that? 0.75, right? It's not 0.75. Negative. Negative. Why? Because it's low. It's coming down, and height. The reference from height is the ground up, right? So the direction or the orientation of height is upward, and if that height is decreasing, then that rate of change is negative, right? Okay. So if y is defined as the height, I want you to define each variable completely and precisely. We're doing this because we want to set this precedent that when you come to real-world situations all semester long, this is how you want to start. You want to understand the situation and model it symbolically. Always. It's not, oh, what formula do I do? What numbers do I get? How do I get an answer? Let's holistically understand the situation first, and that means let's define, really understand what it's saying, and then let's symbolize the things that we're given. So these are, you're going to have written phrases that are the meanings of these variables. If you happen to know a value, then you can state that you know that value, but for now we are determining what are the meanings of these variables. So these are not one-word answers. These are like significantly long phrases. Go. And talk as you do it. Okay, you should have said x is the number of seconds since the flag left the top, or something like that. Something as specific as that. You can't just say time. You can't just say number of seconds. What number of seconds? What's the reference? You need a reference since the flag left the top. Y we said is the height of the flag in meters, so dx is, it's a change in time. So probably better than v would be a change in time in seconds. Dy is a change in height. And m is our constant rate of change, negative 0.75. So first task, write an equation using two or more of those variables that computes the constant rate of change. How would you compute that value m using two or more of those variables? How would you compute it? M equals, what would compute that value m? Okay, what do you think? You said dy over dx. Do you agree? That's right, dy over dx. What about y over x? No, it won't work. Okay? It has to be dy over dx. Constant rate of change, again, it's about the relationships of the changes in quantities. This is always true if you have constant rate of change. Okay, next question. Write an equation using these variables that will compute the change in height for any change in time. Everybody should be able to get this one. Every single person in here. Write an equation that computes the change in height for any change in time using the symbols over there. What computes the change in height for any change in time? So that means we're saying what? What are we saying? Talking about, first of all? We're talking about dy, change in height. And what computes dy? mdx, right? The change in height is always that constant multiple of whatever change in time you have. This is how we understand the value of m. This equation frames how we understand that value of m. That given any change in independent, change in dependent is m times the change in independent. Okay, new situation here for the flag. How much does the height change from starting from 4 seconds to 6.9 seconds since the flag left the top of the pole? What are all these things? And if you know the value, then you could also point out that you know the value. Okay? So model this situation, height changing from 4 seconds to 6.9 seconds. Model it using our symbols. Go. Yeah, take notes on everything, guys. Take notes on everything. Sorry why that happens. I don't understand why that happens.
Write something down. It doesn't have to be right. You can always change it. You gotta try. You can't succeed if you don't try.
So dx has the same meaning. It's still the change in time. Change in time. The change in that variable x, which is the time since the flag started to be lowered. And in this case, what is dx? What's the change in time? 2.9. Final value of time minus initial value of time. Okay, what's the change in height? Do we know it or can we find it? How do we find it? We've got a change in time. And what does that negative 7.5 tell us? Given any change in time, we know the change in height. How do we know it? Negative 0.75 times the change in time. Anybody have that? Thank you. Meters. How can you have a negative distance? How can you have a negative distance? Does that make sense? It's a negative change, which just means that our distance from the ground is decreasing. Has decreased 2.715 meters. So a negative change is always valid. It just means that that variable, in this case y, the height, is decreasing. It started higher and then it's lower, so the change is negative. M we know is the same, x and y. Do we know any values of x? Yeah, we know initial and final. Initial is 4 seconds. Final is. So you could argue that it takes on every value in between those, right? So what is x? It takes on every value from 4 to 6.9. At some point, this flag was coming down. X took on 4 seconds. It took on 4.8 seconds, 4.9, 4.92, 5.1, etc. Took on every value between 4 and 6.9. What about y? What's the value of y, or values? Can we find it? Unknown, right? Why is it unknown? We don't know the initial height, right? Without the initial height, we don't know any height. We don't know any particular height, but we know the change in height. We know the change in height because we have a change in time, right? And we have constant rate of change. Questions on this? So I'll review. Again, we implore you every time you start a contextual situation, and most of your problems are like that. You start by understanding the problem and modeling it with symbols. Do this kind of modeling first. Before you get out of the mindset of how do I get the answer? How do I get the answer? We want to be in the mindset of I want to understand the situation completely, and look at it from different angles and look at every aspect of it. And that starts with good mathematical representation, modeling it with symbols. Okay. All right. So next, okay. Don't try to copy all this down. So if you want to, you can go back to the video, but just get the most important points in your notes. Okay, so new situation. Suppose you open your laptop during class and take notes. 35 minutes after class, your laptop battery has a 41% charge, and 75 minutes after class started, it has a 28% charge. So we'll call the percentage of charge variable P. That's our dependent variable. It changes at a constant rate with respect to number of minutes since class began. We'll call that T. That's our independent variable. Okay? So no calculations. What are the units of the constant rate of change? If T is independent and P is dependent, then what's the units of the constant rate of change? And how do you interpret the meaning of the constant rate of change? No calculations yet? Let's do the whole screen. And then what is the value of dt according to the information given? What does 1/40th represent in this context? What's the value of dp corresponds to dt equals 40? So work together. Talk amongst yourselves. Get help if you have a question. Okay, what are the units of M? You should have said M is measured in percent per minute. Okay? So how about this meaning for M? Its value is the percent change of the battery in every minute of time. How about that meaning for M? Good? Like it? Narrow. Narrow. It's true, but it's narrow. What's the better meaning for M? Better meaning for M. I'll start you off. Given any change in time. Given any change in time. The change in the percent is m times that change in time. So yeah, this is true, but this is the narrow meaning for m. Just knowing how much it changes every minute. We know a lot more than that. We know how much it changes in any number of minutes, right? Any change in minutes. Okay, value of dt is? You should have came up with 40. Final mass initial 40. What does 1/40th represent in this context? What would 1/40th be? 1 minute. Yeah, so it's 1/40th of 40 minutes would give us 1 minute. We'll see why that's important in a second, okay? It's the fraction of time that 1 minute is to 40 minutes. So 1 minute is 1/40th of 40 minutes. See why that's important in a second. And then, what's the value of dp? So now here, normally we'd say like 40m, right? M times 40, but I gave you both dp, so you could do final minus initial, right? So you could just do 28 minus 40. So you got negative 13%. Did you get negative 13% for dp? Okay. Okay, so now let's talk about calculating m. So if it changes negative 13% in 40 minutes, how much does the percent change in 1 minute? So think about this. In 40 minutes, it changes negative 13%. So then how much would it change in 1 minute? So 1 minute is a 40th of 40 minutes. So how much does the percent change in 1 minute? So it would be the same, it'd be 1/40th of negative 13%, right? So if we're shrinking down to 40 minutes and we're saying what happens in 1 minute, well, that's 1/40th. So then in 1/40th of 40 minutes, we're going to get 1/40th of negative 13% decrease, or change, right? So 1/40th of negative 13 is negative 3.2% per minute. Okay, so this is why you do dp divided by dt to get m. So earlier we said m was dy divided by dx. This is the reason why. It's really about multiplication. It's about taking a fraction of that change in the dependent variable. And then division is another way to write that. So the reason it's dp dt is really about a multiplication, taking some fraction of your change in dependent. So that's why you do negative 13 divided by 40 to get this. The constant rate of change is negative 0.325% per minute. Okay. Any questions on that? All right, so again, do not open GC. I'm going to be working in GC, but you should just take notes as normal. So here's that situation. I've graphed the 2 points that were given. So we're going to work on a graph here. And so what's my independent value was time since class started, and I'm going to show the independent value on the x-axis. And my dependent value was the percent battery power. And that's my dependent variable. I'm going to show that in the y-axis. That's conventionally how we do that, right? Independent on the x, dependent on the y. We don't have to do that, but that's just our convention, okay? That's just our convention. That's what we normally do. Okay, so here are those. So what does this point mean? What is the meaning of this point? Right here. Tell the person next to you what the meaning of that point is. That point represents something. What does it represent? Tell the person next to you. Go. Does it represent a 41% charge? Is that what that point represents? No. It's part of it. Where's the 41%? The 41% is here. That's the 41% charge, or where we look for that, or represent that. So that point represents two values taken simultaneously, right? A correspondence point is the value of two quantities taken simultaneously. So we say, that point means that at 35 minutes, the percent is 41. That's what that point represents. The 41 minutes we represent on the y-axis at that same height on the graph, right? Okay, so I got both correspondence points there. And we know that the constant rate of change, we've already calculated that, is m is the negative 0.325. let's jot that down. So now I'm interested in, I want to know what my battery percentage is at 83 minutes into class. So there's that correspondence point. I want to know, what is my battery percentage at 83 minutes into class? Okay, now the process I'm about to show you is critically important. We're going to do it over and over and over again because our experience, we know this does not come quickly for students. So just try. Every time we go through it, you're trying to retain this process. Okay? And there's going to be a point where you're going to be tempted to say, oh, I know how to do this a different way. And maybe that's right. But when we get into the calculus, you're going to need to know this way. Okay? You need to know this process I'm about to show you. So resist the temptation to say, I'm just going to do it my way because I've learned this before. And I know how to get this. This process is going to be critical when we start building up the calculus next week and in the next month. Please learn this way. So here's what we're going to do to find, what did I say? What we want to find. What is the battery percentage at 83 minutes? The first thing we're going to look at is we're going to say, what is the change dt, right? So the independent variable is t, so you can think about that. Always comes first. So the first thing we're going to do is, what's the change in t? And how do we symbolize the change in t? dt, okay? So dt. So we're going to use our reference point as this blue point over here. So we said that correspondence point was what? 35, 41. So I'm going to use that as my reference point, and I have this final value of 83 minutes into class. I want to know what my battery power is. So what is dt? Or how would you represent and calculate it? You can't do it in your head. dt is what? Final minus initial. My final time is 81. Initial time is 83, sorry. Initial time is 35, which means a change in time of 48 minutes. That's step one of this process. The way you can remember it is, you always start with independent variable, right? Independent variable comes first. So I want to know, what's my change in the independent variable? So from 35 to 83. So what's the goal here? The goal is 83 comma what? Question marks go the other way. There we go. 83 comma what? This is our goal. How much laptop battery power do I have at 83 minutes? Okay, first thing, change in t. How can I represent that change in t now? If I start at our correspondence point 35, I want to represent this change, this dt of 48. We did this last time. How can I represent that? Right, and we said that dt was 48, so I'm going to set that dt to 48. Maybe. Okay, so that represents our dt. Step one, find the change in t. So what do you suppose step two is? Change in the percent. Change in the percent. Change in p. Question of the month. Question of the week. Question of last week. How do I find the change in p? We have the constant rate of change, right? The constant rate of change. By definition, the constant rate of change tells us that any change in time, change in percent is that times the change in time. And we've got the change in time, so it's all set up for us to do this. The change in p is going to be, I can't do final minus initial because it's the final that I'm trying to find, right? I'm trying to find the final p, so I can't do final minus initial. But I'm going to use constant rate of change. I know that I'm changing at a rate of -0.325. per minute, which means that dp equals negative 0.325 times dt, which is 48. How can I represent that on the graph? So from there, we can say corresponding to that change of 48, I've got this change. I don't know why it does that. We're back. All right, we got this change of, and what, anyone got that? 15.6. Is that exact? Negative, that's our dp, is negative. Is that rounded or exact? Perfect. That's exact. Awesome. Okay. So we're utilizing constant rate of change to get this second point. As 48 minutes, every time 48 minutes goes by, we're going to lose 15.6% of our battery. Okay. Last principle is one we did in the first week of class. What do I want? So this is like y initial, and this is what? Y final. And so y final is what I'm after. How can I get y final? Remember this principle. Should make perfect sense that I'm going to, if I want y final, I start with y initial and add my change. But these are p's, right? Sorry. P final. P final is P initial plus change. Remember doing that with a smartphone activity? But it should make perfect sense. If you start out with a value and you add the change, you're going to get what you have in the end. So what's P initial? 41. What's the change in P? We just found it, the negative 15.6 by constant rate of change. That gives us the final value of P. So it's going to be what did I say? 41 plus negative 15.6, which equals 25.4%. And so now we've got that correspondence point. It's 83, comma, 25.4. Here's this process that we have to learn. So yes, there may be half a dozen to 10 different ways to get that final answer, 25.4%. This process is a process we need to develop the calculus. So everyone has to learn it, whether you can do it a different way or not. Okay? What's that process? First, find the change in independent by final minus initial. Then use constant rate of change to find the change in dependent. And then we're going to use this principle from the first week that the final value of our dependent is the initial value plus the change that we just found in step 2. Okay, so I want you to do this, and I want you to do this in order to find what the percentage of the battery was at the start of class. What was the percent of battery at the start of class? And I want you to use this process to do it. Everyone work on that. Go. What was the percent of the battery at the start of class using that 3-step process? What do we do first? First thing is change in T. Change in T is first. And that's dt. Okay, so now one thing we're noticing, you guys, it's not d of t. It's not function notation. dt, think of dt as just a single thing. It's just a single entity. That's this variable that means a change in t. So it's not function notation. It's not two different variables. dt is just look at that as one thing. dt. Okay? Change in t. What is dt? Final minus initial. What's the final? Final time? 0. Initial is 35. So change in time is negative 35 minutes. A decrease in time of negative 35. And what does that look like on the graph? We're going to go to the left first. Go to the left first by 35 minutes. So that's our dt of negative 35. Next step. What do we do from there? Change in percent. Change in p. Again, just dp. Not d of p, no parentheses. It's not two different things. That's just one thing. The change in p, dp. How do we find the change in p? By the very meaning of m. By the very meaning of the constant rate of change. The changes in percent are the constant rate times the given change in time. So it's going to be negative 0.325 times negative 35 gives us change in p of 675. So if we decrease time now, our percent's going to go up, right? If we decrease time because we had more battery power before, right? So now it's going up. That's why it's positive. Two negatives make that positive. It's going to go up that much. So then P final equals P initial plus the change. P initial was 41. Change in P equals 52.375%. And now looking at the graph there, does it look about right? Just look and see that point. Yep, 50, somewhere around 52, 53, somewhere in there. So this is the correspondence point of 0, 52.375, or how much battery you had at the beginning of class. Questions on this? Okay, well so that we just found two different correspondence points, the one for 83 minutes and the one for 0 minutes. But I want to do better. I want to get every correspondence point of this relationship. Given any time, I want to know what the percent battery is. Instead of having to do these one by one, I mean, it would take forever because there's an infinite number of them, right? So I want to come up with a relationship that gives me the battery percentage at any given value of time. And to do that, I'm going to use the same process again. But this time, any questions before I erase? Use the same process again, but this time, when we choose the new point, say there, we're just going to say, let that be any point. Let that be any correspondence point, not a specific one. So how can I represent that as any correspondence point that we have? How could I, as an ordered pair, represent that as any correspondence point? T, so any T, right? And any P, right? And we'll use that same initial reference point. We could use this red point too, but we'll just stick with the first one. It's fine. 35, 41. So now, I could have placed that reference point here. I could have placed it here. I could have placed it here, here, here. Why? Because it represents every single correspondence point, and I'm doing that by just saying let it be T, let it be variable, and then the corresponding P. Now we're going to do the process, the same exact process again, but we're just going to hang on to our variables instead of knowing what those values are. So we're going to develop expressions as we go instead of getting numbers every time, right? So you're going to just try the same thing again. See if you can do the same thing again, but you're going to develop and hold on to expressions of t and p instead of getting a number on every step. Is the task clear? So do the same process again. Go. Okay, what's the change in t? T minus 35. And what number does that equal? Depends on what t is, right? Because t could be anything. So we just leave it like that. We just leave it like that. So the change is final minus initial. So now that's our dt. So what's the change in p? Okay, m is m times, which is? Well, we know what that change in t is. We wrote it in step 1. Okay, and we'll just leave it like that. So that whole expression given any time will give us the change in percent from 35, right? The change in percent from 35 minutes into class. That's what that will give us. Finally, what are we solving for? What do we really want to know? We want to know that p right there corresponding to that t. So we just say p equals initial plus this whole thing, the change. Initial plus the change. How many people got it before I started writing? How many people got it before I started writing? Half. Half. The rest. Does it make sense? We're doing the same thing, but now we're just holding on to these variables t and p. Okay, so what is this now? This is a relationship between p and t that gives us all correspondence points. So given a time after class has started, this gives us then the percentage of battery. So it's almost a function, right? Right now it's just a formula. It's almost a function because we have to establish some kind of function notation, right? We haven't done it yet. So it's a formula that is just one step away from being a function. So now I want to graph all these correspondence points. So how do I tell GC to graph something? Use x and y, right? What is p? What is our p? That's a y. And so if I write y equals 41, and I can just go right to minus, right? 0.325 times. And t is x minus 35. And class is 90 minutes long. I'm going to to show all of class, which is 90 minutes long. We're going to show it from 0 to 90. So this is going to plot all correspondence points of a time and the corresponding battery percent for class. Don't want to do green. And there they are. So we derived a relationship for every correspondence point, starting at time 0, and then we show us at 90. Okay, again, we urge you. Yeah, so what is this? This is a linear equation. It's a linear equation. But this is the linear type of linear equation we need. This process in this form is the type that we're going to need for calculus. So the days of mx plus b are over. I mean, yes, we could rearrange this and get mx plus b. This process in this form is what we need to build up the calculus. So please learn this. Don't just say, I can do this my own way. You're going to get into trouble.